Uh, Welcome to this presentation. I'm going to introduce how we integrate this microservice technology or system of working into Letgo. This is a way of working. It works for us very well. It doesn't mean it works for everybody, but for us, it's working pretty well. My name is Andrés Suarez. I'm a former DBA, a current DBA on Letgo. I've been here for about 1 year and a half. Used to be an Oracle DBA for many years, and now I jump into the cloud and MySQL open source technologies. Our company, as my daughter said, is a website to sell things. Well, yeah, it is. We're trying to disrupt the second-hand market in the States, in the United States mainly. We also have other markets around the world. To do that, we have about 80 million registered users into our applications. This is registered user, but daily we have about 6 million users daily using the application. We have about 16 million messages sent to our databases every day, and about 60,000 products posted every single day. To support that, we are a AWS platform. We have every single thing in the cloud. We have about 1,500 servers in peak hour, and about 300 databases. For those 300 databases, we have about 80 different schemas, 80 different microservices. We are officially a very large database company. We have several tables, over 4 billion rows, and very, very big databases in MySQL, over 3 terabytes. If we put all together, maybe they are over 20 or 30 terabytes of data. To support that, we have a mixture of technologies here. We have our core infra is on MariaDB, but we also have some DAS like Dynamo or Aurora. And for quick access or searching, we're using Elasticsearch and Solr. Our basic topology is a master-slave. We try to use Galera, but due to the traffic we suffer every day, it didn't work. So we need to keep going on the master-slave. We don't have any kind of constraints or foreign keys or unique keys on the databases. Everything is on the code, precisely to make everything go faster and more and better. Okay. What is a monolithic database? I think most of you are familiar with the term. A monolithic database is when you put everything in the same database. This is very handy when you start developing a new application or a new tool. The problem is after a few months, years, you start growing the application, you start adding more layers of complexity or adding more microservices, and the databases start getting bigger and bigger. Obviously, once the database is used by more than one single microservices, we have to start having problems because there is constraints between one service can update the database because the other service is waiting, or you can alter the database because the other service is waiting, etc., etc. To avoid this problem, we went to the other. Okay, a monolithic database is difficult to scale because mainly to scale the writes, you can only scale in vertical. You just have to make the database bigger and bigger, which is not the best option. As I said before, it's difficult to scale across teams because we are using an agile technology, an agile methodology, and teams need to put changes to production all the time. It's not once a month, twice a week, but all the time. So they need to be totally or as much as possible independent one from the other. If you have a monolithic database, if the database goes down, everything goes down. The entire platform goes down, so this is also a big problem. And it's forcing all the teams to work in the same technology as well. If you are using MySQL, everybody needs to be familiar with MySQL, using MySQL, and using MySQL the same way. I mean, when you design the database, you create the tables, you create the indexes, you create the VM, the virtualized, materialized views, and all the teams need to be confident and familiar with that and just to work with that. Well, in a microservice database, this is more like splitting the problem into smaller problems. This is not the best solution for everybody, but for us it's working pretty well since it's giving us the flexibility of the teams working in parallel in the same data without actually having so much problems of constraints, blockers between teams. The main objective for a microservices database is the security. For us, every microservices has its own data. They can write only in one database, that is their database. They can use shared data from other databases, but they cannot write in any other database but their own. This is the same, the ownership. They are responsible only for their data. They are not responsible for the corruption of other databases or other data that they are not owner. Well, there is a problem here, right? The problem is when you need to share the data among different microservices. To solve that problem, we just create what we call a projection. A projection is a shared data, a shared table that exists in different databases. Of course, there is a problem here. Well, it's not a problem, but how do you synchronize that data, right? I will say that later. Using the microservice database, you can split the load easily because every single microservice has their own database, so there is no problem. If you launch a campaign or you launch a big, I don't know, anything very heavy on the database, it's not going to affect other services or other databases. We're using event to populate the projections. The event is the key for doing all the things together. The event basically is every write or every modification in the database is being used by the event. Okay. And also using the microservice database allow us to fail fast. I mean, if our microservice is not working correctly, we can put it down in the system within minutes without affecting other databases or without having to rolling back changes in the production, more critical databases. Okay. The good, as I said before, it scales horizontally. You can create more databases, you can create more microservices, and just adding more databases with more slaves or writes, splitting the writes across the entire infrastructure. Also, the good is that actually you can work with different engines. You are not based on MySQL anymore. You are not based on MariaDB anymore. You can use Elasticsearch. You can use Solar. You can put the data that you are going to query in any engine you prefer. That is very handy for us because actually you can decouple the database and you can store the data in a format that your microservice is going to be more confident with. Same thing for the configurations. You can create a projection in another database with different index, so the table actually can be in a different way. That is going to be much faster and better for this read-only use. Fit very good in the Scrum methodology. This is allowing us to go from one team to the other without affecting and without cross dependencies across the teams. And the fallback. The fallback is basically In some cases, we can get the projections corrupted, not corrupted, but the data can get lost or not inserted correctly. So the fallback is the way we're using to synchronize the data across the entire system. That is, sometimes you can get the data populated in the main database, but not in the other projections. So from time to time, we need to call back this fallback process that synchronize the database to make everything the same. Okay. So far, so good, but obviously it's not perfect. It has some limitations as well. One of the limitations is when you have to do some modifications on the structure, on the table structure. Before, in a monolithic database, you only have to go to one database, do an alter, and that's it. Now you have maybe 30 databases with other structures similar that you need to cope with. If they are NoSQL or if they are schema lists, there is no problem. But some of them, they are actually MySQL or fork of MySQL, so you need to coordinate with all the teams to make the changes in a way that affect the application as less as possible. And data incident, this is the same. You can get, maybe due to a bug or a SQL injection or anything, the data get corrupted, and you need to fix the data in several databases, not in a single. You don't have anymore a single point of failure, but you have many points of failure, so you need to fix the database in many databases, fix the problem in many databases. That is actually sometimes very a nightmare. And the bad is the clean data. Data can get inconsistent sometimes. Like that's the way we use this fallback method to synchronize the databases across all the entire system. And of course, cost increase. I mean, it's not the same having a single database than having 5 databases. The resources are going to be smaller, but still you need to manage the databases, prepare backups, prepare HA, etc., which is the manageability as well is going to be much more complex and much more bigger than in a monolithic database. Everything is clear until now? Any question? Yeah.
Would you be able to spend a little bit on the manageability and how do you guys feel about that? Imagine having, I don't know, 30 different kinds of database schemas and having to put something into the times and you're having to maintain sometimes all these different databases.
Well, to deal with that, basically what we do is it's complex. It's no easy question, that one, because normally we don't have my role, for instance, is not DBA anymore. I'm not expert of MySQL anymore. I'm a data expert. I need to know about SQL, but I need to know also about schema lists. I need to know about, my knowledge is arranged about everything. I'm not a MySQL expert anymore. I just know about everything a little bit. Enough to give support to the devs, because obviously they don't know about data. They do, but not that much. And also trying to explain them how it works. I mean, to explain how it works, first we need to understand how it works. It's not doing a commit on Elasticsearch, but doing a commit on a NoSQL, that doing a commit on MySQL database. I mean, talking about the ACKs and about the commit, about the buffer. So to handle that is since we are doing Scrum teams, it's not that complex because you are participating from the beginning. It's not that you come at the end and they come with the solution and, oh, we're going to start working with Elasticsearch. They call you at the beginning. We're thinking that. What do you think? How do you do it? Is it a good approach? We need to be involved at the beginning. If you get at the end, it's too late. Because sometimes they come with ideas that actually they won't work. So you need to be at the beginning involved, trying to tell them, no, for this particular case, we don't even need a database. You can store it in a S3 or I don't know. So it's, as I said, the key thing here is to be at the beginning of the meetings. When they start taking the stakeholders and taking the features requirements, be there. This is the key concept for me.
So I guess you're saying that this is not a software-driven solution to be your case. It's more of a role and position. It's a case you are responsible to make sure that all these different systems
Yeah, exactly. It's not DBA anymore, but it's a cross-platform data engineer or something like that. Okay. Also collaborating very closely with the DevOps team for those procedures of patching or increasing or changing the version of that, roles or grants, all that. Working very closely with the DevOps team that give us a hand on that. Yeah. I'll go through that later. I'll go through that later. Okay. Okay, this is a basic monolithic database, how it works. I've been using this kind of architecture for years. There is more layers in the middle, there is more things, but this is the basic concept. You got an application that sends the writes using your driver, your JDBC driver to the database. As I said before, this way of working is fine as long as you can scale in vertical on the database. Stop being so good as long as you have more than one single application right into the same database, because you start to get constraints between the databases, between the applications. To do the move, first using event. Event is the key for all that. For us, without the events, we wouldn't be able to do that. There is other ways to synchronize the databases like ETLs or projection but with the events, allow us to populate all the databases, not only the write database, but the read databases, without having to depend on a technology. A technology, I'm talking about MySQL replication or a certain technology. The event is a write into a database that is agnostic. They don't care how it's going to be write. Okay, using queues and subscribers. The events are sent to the queue, and then we use the subscribers to plug our code into the subscriber, get the event, and after that insert the event into the database or the backend. Training. Training is a good point here as well. As I said before, you need to be at the beginning of the taking decisions, to talk to the developers, to talk to the DevOps, because sometimes the jump is complex. People is more familiar with the basic, the old school architecture, and sometimes it's quite hard to try to push them into, don't use one single database, use two databases, or use a projection on a NoSQL database. Okay. Projections. Projections is nothing else than a view, basically. It's a view, but that view is persisted in a different database. For this particular scenario, we have the product service and the customer service. The product service, in this case, is the owner of the data. Is the responsible of the data. They need to guarantee that the data is always correct on their end. In the other end, the customer service is only a consumer of the data. It's only a read-only user. In there, there's the queue. I put two SQL here, but actually it could be anything. Could be a Mongo, could be Dynamo, could be whatever, Elastic. As you see, the table structure is different. You don't need to keep all the data, because actually you don't need all the data here. For the customer service, we don't need that data. That guaranteed security issues. For instance, not all the services is getting the data. It's very Suarez compatible, because your read model is completely different to the write model. Okay. And doing the move. As I said, this is how a monolithic architecture would work with the queue and events. Okay. The consumer bit is the one that queries the queue and insert the data into the database. In that case, it's writing in PHP, but in a microservice architecture, we have application sending the events to the queue, and two different consumers. The consumers can be writing in any language your team is working at. There is no constraints about a particular technology anymore. If you are familiar with Java or Scala or anything, you can write the consumers in any language you fancy. And also the DBs can be writing in any database you fancy as well. It can be Elasticsearch, can be Mongo, can be MySQL, can be Oracle. So in that case, there is two teams, two different teams, using one event to populate two databases. In this particular case, one of them, DB1, will be the owner of the data, will be the responsible of the data, and the DB2 will be only the reader. So they don't need to do backups, they don't need to guarantee that the data is there. They only need to make sure that the data is right in here. So if the data is not there, they need to query the DB1 to make sure the customer doesn't get affected. Okay. That could be if you get the product application and the client application, how may it work? There is two applications, they have two different queues, but we can see here how the customer 2 is querying the product to populate the product table. While all the other traffic will come through the customer 3, customer 4, any other consumer you have. In this case, I only wrote 2 queues, but we have, I don't know, 100 of queues. Depends on the event you are sending and okay. Any question? You see? Good. Okay, what happened if the event gets corrupted or is not properly done or there's a bug in the code or anything? To do that, or even it's a downtime in the database, we do we call a dead letter. If the event, we try a number of times the consumer tries a number of times to get the event done. If they cannot reach it, we populate a dead letter so we never lost any data. That event into the dead letter queue can be processed later. We can troubleshoot the problem, so the events are never lost. Of course, there is another problem that the consumer has a bug. Since you have two different consumers writing into two different databases in a asynchronous mode, you may face the problem that one of the consumers has a bug and the data is not populated correctly into one of the databases. In that particular case, is what we call the fallback. From time to time, we need to synchronize the databases and make sure all the data is consistent across the databases. And really, well, that's it. If you have any question, something I can help you.
What message queue system are you using?
What do you mean?
RabbitMQ?
No, it's everything in Amazon. Yeah, everything. We have everything in the cloud, so we have SNS and SQS queues, but can be RabbitMQ. The thing with that is everything is integrated into the cloud, so it's less management for us. But to be honest, could be anything. Yeah.
And another question is pretty interesting. What challenges did you find when eliminating primary keys and foreign keys from the database and putting that into code?
The challenge mainly was where we were used to use that technology. So now we do use from primary keys. We do use primary keys, but we don't have any unique keys or yeah, sometimes get duplicates. Sometimes you get duplicate data, so you need to be very careful with that. But on the other hand, it's faster, and we need to be faster because we have very lot of traffic. So even when we know sometimes we fail, for us it's better to fail sometime than be slower. Because having unique keys, do it to the events sometimes get corrupted, get duplicates, they don't get an order, and sometimes we have a lot of errors. So the unique key is a very, very ugly error because it fails when it goes to write into the disk, and the exception is very, very awful. So yes, actually, this is worse than get a duplicate for us, for a particular scenario. I don't say this is a part. You're welcome. Yeah. Mhm. Yeah. Well, depends. Yeah. To manage that, the queue, the events are ordered by data. So they are ordered by the time they were tried to be processed. So we put it back into the queue, and depends on the particular issue, we can just put them back into the original queue and reprocess. Or if there is a bug or something in the code, we may need to regenerate them. If we need to regenerate them, this is we need 3 hours to talk about that because it's quite complex. But normally, I would say 85% of the cases, we just need to get the dead letter, put them back into the original queue, and everything works again. No, because we provide avoid race conditions because we check the update at. For instance, before if you are going to insert something, if it's already in the database, it's not going to insert, it's going to fail. So we catch that exception. And if before updating anything, we check the update at, just to avoid any race condition of putting back all data into the correct. Overriding all data overriding new data with old data. Is that clear? Yeah.
Hi, thank you for your time. One quick question about how do you explain to developers when moving from a monolithic database to having more databases? How do you deal with consistency when reading, writing, for example, and
Yeah, well, actually for developers, they are very kind of doing these kind of things because you give them flexibility. For instance, we are about 12 teams, and when you tell them you're going to be able to go changes in production anytime without dependencies in other teams, they are like, oh, okay. They're like, because actually for them it's good. The problem is for the infrastructure side. And the eventually consistent problem is that events are going to get right at any point on time. The thing is, if you are using one of the projections, at some point you may get the data here before there, because obviously the queue is not synchronized, it's not synchronous. But we care. We actually, it's important for us that this is not synchronous, because if it was synchronous, it wouldn't work. If we need to be committing all the databases at the same time before say, hey, it's okay, it wouldn't work for us. So we manage that saying, okay, if there is no here, we need to query here. But it doesn't happen that often. It happens normally when you get this table corrupted or some bugs in the. Normally, when the first thing we do is a migration. When we take the decision, we're going to create a new microservice. Are you going to have dependencies on product? Okay. What engine are you going to use? Elasticsearch. Okay. So we migrate the product they are interested in into their projection. After that, the data gets populated in the same flow. But data is never modified here. This is important. Application never modifies this data. Only modifies this data.
Yes.
If you need to communicate, for instance, if this application needs to send a write here, you need to create an event. You never communicate directly between those two.
But if you have a read after that write, then that read is not consistent with the write, then in the application maybe to see that old data,
Yeah.
and you have to deal with that like you said, right? So how do you try to explain that to developers that they have to take care of
The reads are always consistent. The inconsistency comes from the write. Well, but this is not inconsistency, it's eventually consistent, basically. The commit is going to get there, but it's going to get there not now. Sometimes you need to retry, but also, if it's not here, because it has been created, probably the customer service doesn't even use it yet, because every single scenario needs to be discussed and go through. But most of the cases, the point here is that it will be consistent. It's going to be eventually consistent. The data is going to be there. Maybe not in the same point on time, but it's going to be there. So no, I need to be there in the same time. That's difficult to manage. Even in a master slave, if you are using a topology master slave, and I need to get in the slave the data at the same time that is writing in the master. You won't get it. You won't get it at the same point of time because there is a lag. So you need to go through every particular scenario and talk to them and try to see what is the problem and how to solve it. Yeah.
How does the application manage the join between several tables from different databases?
Projections. Actually, if you are going to need a file table join, if it's going to be file table join, we create a projection with and persist the data in that format. To avoid to have 5 projections, you populate the 5 events into one single projection. So in that way, you add the complexity in the event layer, but then the application goes very, very well. Yep.
How many views do you have more or less?
I don't know, a lot.
How do you manage them?
That's the DevOps team.
So it's like through Amazon Services user interface, or do they have like
No, it's Amazon user interface. And
clicking screen, like making queues?
yeah. And then we support them using some tools and puppets and
It's like hundreds of views.
yeah, more or less. Okay. Yeah. Uh-huh. We don't have a recursive. It doesn't run every hour or every 3 hours. It's basically when we detect any problem. We can say it's a post-mortem. After we detect a problem, we run the job. It doesn't run that often. We don't need to run it that often. But after we get any complaint or alerting system is detecting inconsistency in the data, then we go to the team and say we need to fall back and repopulate that projection because it's corrupted. Well, it's not corrupted. It's just the data is missing some few records, or data maybe has some race conditions, and that problem maybe many times comes from the code. Many times comes from here. Sometimes there is a bug in the code, and you didn't populate the data correctly into your projection. And we need to, for this reason, we need to talk to the devs, and we don't want to do it, automatically, because if there is a bug here, we need to be aware of the bug and solve the bug. Because if we do the fallback automatically, the bug is going to be there, so it's never going to be fixed. Okay. Yep.
Andrés, one question around high availability. So this architecture, based on what you just said,
Mm-hmm.
really helps scaling out
Mm-hmm.
your runs. Right?
Yep.
So what about high availability? Are you able to use the very same architecture for that as well?
Yep.
So as an example, let's say the example you gave where you had a consumer of the product.
Mm-hmm.
Let's say that server goes down and node goes down. So what would you do there?
Okay.
Right there.
If this system goes down,
Yes. Well, if that one goes down, then which is the projection, that one will take over? Is that
you can direct the traffic to here.
all right. What about the other
If this goes down, you need to do a fallback. Because probably you have event here that is not in the owner database. That's completely wrong for us. But as I saw you in the deal letter, in the deal letter projection, if the events are there, if the system goes down, the events are going to be in the letter a queue. So later we can reprocess the events again into the product database. So we actually were not losing anything. Okay? Since the consumers are independent, you are writing in one, but just imagine this system goes down. The system can detect the problem and queue all the events, and later, after the system is up and running again, you can actually, we're doing that for when we need to take, I don't know, any maintenance or any changes in here. We cut here, we cut the consumer, everything goes into the letter. You apply the changes you have to during the maintenance. When you finish, you put it up and running, and then reprocess all the things in the letter again. In that way, you are affecting, but you are not losing data. Because the customer actually has the impression that everything is working fine, even when the system is down. Obviously, for doing HA, you have a replication manager and proxy SQL to try to reduce as maximum the time of recovery. But as I said, in any maintenance window that we have, we stop the consumer, put on the database, apply the patch or whatever you have to do, start database again, start consumer, reprocess of events again, and everything works magically. Sometimes. Okay. Thank you all. A lot of people.